So for today, we are going to learn about parallel lines and transversal. So we're going to learn to identify relationships among pairs of interior and exterior angles formed by two parallel lines. Oh, where's my picture? Well, so let me draw in what you have on here. Is what? Let's see, this is I think. So this diagram kind of matches what you have. Again, I drew it, so it's not perfect. So in geometry, a line segment, or a ray that intersects two or more lines at different times or at different points is called a transversal. So in this diagram, line AB is an example of a transversal because it intersects lines L and M. And then note these four numbers up here at the top. 4 angles are created by that intersection. So there's angle 1, angle 2, angle 3, and angle 4. And then the same thing happens down at the bottom. You have angle 5, 6, 7, and 8. Hey, look, there's my pictures. So line AB would be your transversal. It's intersecting lines L and M, or it intercepts them. So by definition, a transversal in a plane, a line is a transversal if it intersects two or more lines, each at a different point. So here are 2 examples of transversals. Sometimes the lines that are being cut by a transversal are parallel, sometimes they're not. So the example on the left, lines L and M are parallel to each other. So T's that transversal, but lines L and M are parallel, which is what we're going to focus on today. But it's also possible, the example on the right, when you have non-parallel lines. So if I would continue lines B and C, they would cross at some point. Down at the bottom left, if I continued both lines, they're not parallel because they would intersect each other. So 2 lines divide the plane into 3 regions. The region between the lines is referred to as the interior. So that first blank is going to be interior. So the interior is the area or the region between your 2 lines. The regions not between the 2 lines is referred to as the exterior. Those blue regions right there are the exterior. So first blank is interior, second blank is exterior, and then you have that diagram that shows those 2 regions. When a transversal intersects 2 lines 8, angles are formed. So in that blank, you need 8. These angles are given special names, and we're going to work through those. So alternate angles lie on opposite sides of a transversal. So alternate angles have to be like one. Here's my transversal. One has to be on the left, one has to be on the right. So angle 4 and angle 6 are on opposite sides of our transversal. Same side angles are on the same side of my transversal. So angle 1 and angle 4 are on the same side of my transversal, so they're same side angles. Interior angles mean they lie between the 2 lines. So interior angles will be angle 4, 3, 5, and 6. All 4 of those angles are interior. They're inside the 2 parallel lines. The other option would be your exterior angles. Those exterior angles have to be outside your parallel line. So 1, 2, 7, and 8 are exterior angles. Some vocab terms here. Alternate interior angles. Alternate means they're on opposite sides of your transversal. Interior means they have to be inside the two parallel lines. So we have two sets of alternate interior angles. So beside that, I want you to write angle 3 and angle 5. So in this diagram, angle 3 and angle 5 are alternate interior angles. The other pair would be angle 4 and angle 6. So angle 3 and 5, alternate interior, angle 4 and 6, alternate interior as well. The next one, alternate exterior angles, opposite sides of your transversal, but this time outside of your parallel lines. So I can't take anything inside. So if I go with angle 1, I have to go to the opposite side and exterior to get to 7. So 1 and 7 are alternate exterior angles. And then the other pair would be 2 and 8. So 1 and 7, alternate exterior, 2 and 8 are also alternate exterior. Same side interior on the same side of your transversal and between the lines. So same side interior would be 4 and 5 or 3 and 6. So on the same side of my transversal, but they must be between the lines. So 4 and 5 or 3 and 6. And the last one, same side interior angles are on the same side of the transversal, outside of my lines. So that would be angle 1 and angle 8. So they're the same side of my transversal and outside of my parallel lines. So 1 and 8 would be a pair, and then 2 and 7 would be the other pair. And we're going to practice some of these. So if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. Should be R. So if we look at this diagram, if I want alternate interior angles, angle 4 is interior. If I want to do alternate, that means I have to switch to the other side, which would be angle 6. So these two angles, angle 4 is congruent, here's our symbol for congruent, to angle 6. Those are alternate interior angles. There's also another pair of alternate interior angles, angle 3 and angle 5. So angle 3 has to be congruent to angle 5. All right, next one, two parallel lines. Again, key that the two lines are parallel. Then each set of same side interior angles is supplementary. Which means they add to equal 180. So here I've highlighted your same side interior angles, so 4 and 5, and 3 and 6. So if I would take the angle measure for 4, add to it the angle measure for 5, it has to equal 180 degrees. The same thing's true if I would take angle 3 plus angle 6, it's got to equal 180 degrees because they're supplementary. The next one, same side exterior. So same side exterior angles are supplementary. That's a U.
So both answers were supplementary.
And then here I have highlighted angle 1 and angle 8 are same side exterior angles that are supplementary. So angle 1 plus angle 8 has to equal 180 degrees. And angle 2 plus angle 7 also equals 180 degrees. That's what it means to be supplementary. Next, we're moving to alternate exterior angles. So here are my alternate exterior angles, angle 1 and angle 7, angle 2 and angle 8. They are congruent. I can zoom in.
Oh.
My screen's different then. So here we know that angle 1 is congruent to angle 7, which means if angle 1 is 80 degrees, then angle 7 also has to be 80 degrees. If angle 2 is 100 degrees, then angle 8 also has to be 100 degrees. So that's alternate exterior angles. If we have two parallel lines cut by a transversal, then each pair of our corresponding angles is congruent or are congruent. So here we have 4 pairs. They're all different. So my red angles, the top left at each intersection is congruent. The bottom left at each intersection is congruent with our black lines. Then our blue lines tell us that those angles are congruent, as well as the green ones. So if I said this was angle 1, it would be congruent to, let's say, angle 5. Those are congruent to each other. If I labeled this 2 and this 6, angle 2 would be congruent to angle 6. Oops, I didn't write. If I labeled this 3, 3 would be congruent to angle 7. So angle 3 and angle 7 would be congruent, and then 4 and 8 would also have to be congruent. So there's 4 pairs of congruent angles by corresponding angles. So quick rundown on that. They're listed for you. Oh, we skipped vertical angles. So here are types of angles that are formed when a transversal cuts 2 parallel lines. Congruent angles, alternate interior, alternate exterior, corresponding and vertical. We didn't talk about vertical, so we're going to draw ourselves a picture real fast. Maybe. So vertical angles happen anytime you have an intersection. This angle, oops, this angle here is congruent to this angle here. So vertical angles would be this angle is congruent to this angle, but also this angle here is vertical to this angle here. So there's 2 pairs of vertical angles there that are congruent. And then supplementary, supplementary means they add to equal 180 degrees. So same side interior angles, same side exterior angles, and linear pairs. Excuse me, all add to give you 180 degrees.
Will always be 100.
Excuse me. If they're same side interior, same side exterior, or a linear pair, it'll always be 180. So here, vertical angles are opposite angles formed by intersecting lines. They're always equal, whether we have parallel lines or not. So here we can talk vertical angles. So these red angles right here, these two angles are congruent to each other because they're vertical. These two angles are congruent to each other because they're vertical. And then we can do the exact same thing down here and get another pair of vertical angles. So angle 1 and angle 2 are congruent, angle 3 and angle 4 are congruent, angle 5 and angle 6 are congruent, and then angle 7 and angle 8 are congruent. So a linear pair, that means we have adjacent supplementary angles. A linear pair just means that when I push them together, they form a straight line. So looking at angle 1 and angle 2, if I put those together, which they're already put together for me, they form a straight line, which means that angle 1 plus angle 2 has to equal 180 degrees. Same thing's true down here about angle 5 and angle 6. Angle 5 plus angle 6 has to equal 180 degrees. And I could do that lots of different locations around these intersections. I could do these two angles together. 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 We already did 1 and 2. So just at this top intersection, there's 4 pairs of linear pairs. So 4 different ways I can add to get 180. Same thing happens at the bottom. So you could do D and 6, 6 and 5, 5 in that blank spot and D. And they always add to give us 180 degrees. Oh no. So here we're told that line S is parallel to line T and line C is parallel to line D. So we have 2 pairs of parallel lines, and we want to know all the angles congruent to angle 1. So angle 1 is congruent to angle 6, first of all. Well, it doesn't really matter. There's lots of orders you could go in here. I know it's congruent to angle 6 because they're vertical angles. So there's one pair. So I know this is congruent to this. I also know that angle 1 is congruent to angle 9. Because they're corresponding. I know that angle 1 is congruent to angle 14 because they're alternate exterior. So they're alternate exterior angles. We haven't done anything with the right side yet. Now we get to go with the right side, so I'm going to jump to transversal T. Angle 1 is corresponding to angle 3. So if I'm ignoring this bottom line down here, I'm just looking at these top 2, 1 and 3 correspond to each other. So 1 and 3 are corresponding. Angle 1 and angle 8 are alternate exterior angles. So they are also congruent. Now, when I jump down here to this bottom section where angles 11, 12, 15, and 16 are, I don't have a direct relationship to angle 1, but since I know information about both of these, the angle 3 and angle 8, and angle 9 and angle 14, I could make assumptions because I know if angle 1 is congruent to angle 3, and angle 3 corresponds with angle 11, then those have to be congruent. So angle 1 is congruent to angle 11 because angle 3 corresponds to angle 11. So that one we kind of have to go around our ways to get where we want to go. And then last but not least, we have angle 16. So angle 1 is congruent to angle 16. I could justify this multiple different ways. I could say angle 16 is a vertical angle to 11, which we've already proven is congruent to angle 1. I could say that it is corresponding to angle 8. I could say it's alternate exterior to angle 3. It's also alternate exterior to 9 and corresponding to 14. So there's a bunch of different ways I could justify this. I'm just going to go with it. It's vertical to angle 11 because we just said that angle 11 was congruent to angle 1. So in this diagram alone, oops, I didn't mark the last one. There are 8 angles here that are congruent to each other. Can anybody make an assumption about the other 8 angles? Wild guess. So if these 8 angles are congruent to each other, the other 8 angles are congruent to each other. They don't have to be like angle 2 is congruent to 5, 4, 7, 10, 13, 12, and 15 if we were asked that. So let's practice. So if angle 1 is 120 degrees, we're asked to find the remaining angle measures. There is a question exactly like this on your next test. So I want to say, the first thing I always go to is vertical angles. Angle 1 is a vertical angle to what angle? 4. So I know that angle 4 is 120 degrees. Automatically. I know that 1 corresponds to what angle at the bottom intersection. So if I ask you corresponding, I'm looking at this intersection, I'm in the top left. If I go down to the bottom intersection, what angle is in the top left? 5. So 5 has to be 120 degrees. So does 8 because 8's vertical to angle 5. So it's also 120 degrees. So now I'm going to go all the way back up to 1. What do I know happens if I add angle 1 to angle 2? What's it form? A straight line. So they're supplementary. So I know that angle 1 plus angle 2 has to equal 180 degrees. If angle 1 is 120, what's angle 2 have to be? I'm 60. Yeah. So it has to be 60 degrees because if I take 60 plus 120, I've got to get 180, which I do. So angle 2 is going to be 60 degrees. You got it. So is 3 because they're vertical angles. 2 corresponds to 6, so 6 has to be 60 degrees. 2 is alternate exterior to angle 7, which means it has to be 60 degrees. So really, anytime you have 2 parallel lines cut by a transversal, you have 2 angles, and then you just have to fill them in the right spots. I think it's worth like 7 points on your next test to do exactly what we just did. So it's worth quite a few points. It's not that difficult. I'm going to tell you one angle. You're going to use that one angle to fill in the appropriate other angles. Questions on this one? The next one. There.
Did you put the 60 there or did it just float from the bottom?
It floated from the bottom. So here we're asked to find all the missing angle measures. Let's start at the bottom right-hand corner. Bottom right-hand corner looks the easiest because I know I have a vertical angle here. So that has to be 120 degrees. How do I find this missing angle in here?
It's the same as the 60.
It is 60. Yeah, you're right, it is. It's alternate exterior to that 60 degrees up at the top. So we know this has to be 60 degrees. You could also use the fact that these two angles are supplementary. 180 minus 120 gives us that 60 as well. Which means that 60 is a vertical angle to this 60. Just for fun, we're gonna forget about this line right here for a minute. This 60 up at the top is vertical to what angle? This one down here or this one over here? So 60 has to be brought over here. We're gonna bring that line back. The 40 is vertical to what angle?
The bottom.
The bottom middle, so this has to be 40. How do you think we're gonna figure out these two that are left? So 60 plus 40 is 100, which leaves us what for this other angle? 80. So this has to be 80 degrees, which means what's the other missing angle at the top? 80. All right, going to the bottom intersection. The bottom intersection, I have something that corresponds with this. It's really easy. So 80 corresponds down here to the bottom, right?
Oh,
Because you're gonna ignore this line right here. So ignoring that line, you would have to add these two together, add these two together. That would give you a value of 100 here. And then again, you can use those vertical angles to fill in the missing two. So this is 100 and this is 80. All right, one last thing. Oops. All right, so when you have parallel lines, you have a diagram over here showing you interior has to be angle 3, 4, 5, and 6, exterior 1, 2, 7, and 8. Alternate interior angles are congruent, so we're going to list a pair of alternate interior angles just for more fun. Alternate interior, I have to pick numbers 3, 4, 5, or 6. Alternate means they need to be on opposite sides of my transversal. So I have to pick 3 and 6 or 4 and 5. So 3 and 6, 4 and 5. Alternate exterior angles are also congruent. So alternate means they're on opposite sides of my transversal. The transversal is the line that's cutting your two parallel lines. And exterior means they're on outside of those parallel lines. So I would pick angle 1 and angle 8. So 1 and 8, or 2 and 7. Same side interior, so now on the inside of my parallel lines, same side of my transversal will be 3 and 5, 4 and 6. And those are supplementary. I can add them together to equal 180. Same side exterior would be supplementary. I could take those angles and add them to get 180. That would be angle 1 and 7, 2 and 8. And then corresponding angles are always congruent. So there are lots of sets of corresponding angles. I could do 1 and 5. I could do 2 and 6. I could do 3 and 7. Or 4 and 8. So all 4 of those pairs are corresponding angles. They are congruent. The only thing we didn't review on this list is vertical angles. There are, again, 4 pairs of vertical angles. They're opposites here. So 2 and 3 are vertical, 1 and 4 are vertical, 5 and 8 are vertical, and so are 6 and 7.